Hi everyone, welcome to Vishwablooms. So in this video is all about the most asked and awaited video. So many of you have asked for physics techno of class 9. So like Batu Shanmukh, Srija, Dashari Shrinu, Sai Satvik and many others. So that is why today we are going to start optics concept 1 class 9 physics techno. So let's begin. Before going with the classic definition, first we'll understand this. So in the first concept, we're going to see completely something about refraction. So you would have already heard this word. Okay, so in the 8th standard, we have been studying about reflection, and now in 9th standard, you will be learning about refraction. So refraction may be something new to you, but these examples of refraction, you might have experienced it earlier. Okay, like now here you have on the left hand side, you have a picture which I have placed it. So here what is going to happen? A straw is placed in a glass of water, right? So here normally how the straw must be, straw is something like this, yeah, but here do you observe that it is getting bent or it looks like it's broken? Why so? That is all because of refraction. Now to understand this topic even more clear, you can try this experiment. That is one, and also I'll give you a simpler one which you can easily do at home with available things. Here not only straw can be used, you can also use anything like a pencil you can use, or pen, whatever it is. If you keep it, what is going to happen? It is going to be broken. It looks like it's broken. Clear? So that phenomenon is refraction. Okay, we'll see the definition in the upcoming slide. Okay, so first let's understand the phenomenon. So let me tell you one more experiment. This experiment is really very magical and very nice to know. Okay, so first you just take one bowl. Okay, here actually you're supposed to take only one, but to make for giving more clarity on it, I have drawn two so that you can understand the first part and second part as well. So ask your friend and you, so both are needed for this experiment. Okay, so first let me tell you what to do here. Okay, so first take a bowl. Here I have taken a bowl. So in that bowl you just place any coin. It may be either 2 rupee, 5 rupee, whatever coin it is, some coin. You can simply place it inside. So this is a coin, imagine this to be a coin. Okay, so you will place that. So I have placed in such a position like this. Okay, so make sure you also keep it correctly in the base. Now your friend is your friend F. Okay, now what you have to do is you have to go back till you don't see the coin in the bowl. Okay, you have to go back till you don't see the coin in the bowl. Suppose this is that I, till there you now you can't see the coin in the bowl. Okay, in that way you can go back. Now ask your friend to pour water in it. So he will pour water in it. Okay, now after he pours water in this bowl, what happens? You feel that coin is here. Yeah, you can see the coin. You'll be very much surprised to see that you can see the coin now. Now, how do you see that? Let me tell you. You feel that coin is here, okay? The green part or the dark blue, whatever it is. So, you see that, you think that the coin is lying this way, okay? But the coin doesn't change its position. It will be there only where you have placed, but due to the refraction of light, it looks like this. Actually, it has here refraction has taken place. Here bending of that light has taken place, but our brain don't know that. That's why it will show the image here. Understood? So you will be thinking that it appears here, but generally it is not there. Okay, so this is one of the experiment, very easy experiment you can do for refraction. Maybe you have already done in your science expo. Okay, so these are two really fun experiments you can try and understand refraction. So I hope you found that interesting. So next we'll see the definition of refraction. The phenomenon due to which traveling from one optical medium to another optical medium. So here what happens? The phenomenon due to which a ray of light actually deviates from its original path. So look at the definition once again. The phenomenon due to which a ray of light deviates from its original path while traveling from one optical medium to another optical medium is refraction. So in the previous experiment here, actually the path has to be like this, right? But it got deviated from the original path, that is like this, right? So it got deviated from its original path while traveling from one optical medium to another. Now what is this one optical medium to another? See, now the medium, you know what is medium, right? Medium is nothing but material. Okay, so from one material to another material. Material is like air is one material, water is one material. So here they have used a word called optical medium, means something which is transparent. It's like transparent mediums. Okay, so transparent medium. So here what are the transparent mediums? Can you guess it? Yeah, try. So first one is air and second one is Water, because we are standing in air, right? Obviously the eye is in air, whereas the coin is in water. Okay, so that is why when a light ray is traveling from one optical medium to another optical medium, the path of that ray, it will get deviated from the original path. That means it will get bent. A little bent will be there. Here this bent is there, right? That's what. But it appears to be here. So I hope that is clear to you. Okay, so let me give you one more definition for refraction. The phenomenon of a change in the direction of propagation of light when it passes obliquely from one medium to another is refraction. The phenomenon of a change in direction. So here what is happening? See, obviously direction is changing, right? So change in direction of light when it passes obliquely from one medium to another. Now what does the word obliquely means? Obliquely means incident at an angle. So this ray of light, it will be incident at an angle, so that is going to make one angle, okay, from one transparent medium to another transparent medium. So these two are transparent medium, am I right? So that is what, okay, so that is refraction. So I hope until there it is clear to you all. Now let's continue, let's move on to the further topic. So now before moving on to the laws of refraction, let me just end up with something. Okay, so now we're going to take two mediums. So this actually I'm explaining to make you even more clear with refraction, how you make the diagram. Okay, so we are having two mediums. The first medium is air. Second medium, I'm going to take it as one glass slab, or you can write it as glass. Okay, so here what is happening? A light is being incidented here. So this is the incident ray. What ray it is? It is the incident ray. I'm sorry. And this blue color line is nothing but the refracted ray. Okay, so when a ray is incidented, now when it is moving to the glass slab, what is happening? This ray of light is moving towards the normal. This dotted line is normal. Okay, this blue line is moving towards the normal. That is the refracted ray is moving towards the normal. Okay, so why is it moving? Due to some reasons, and we will learn that reasons further. So first, this is nothing but refraction, this phenomenon. So this is angle of incidence and this is angle of refraction. Okay, so you need to know this, very much important thing. Okay, now, and also this point is there, right? This point is nothing but point of incidence. Point of incidence, I'm sorry. Okay, so yeah, I hope you understood until here. So now let's look at the laws. But before that, during refraction, what are all the things which is going to happen? Phase of vibration of particles remain constant, and frequency also it is going to be constant, and speed obviously. Now this is one of the important thing which we have to discuss. Speed or velocity, it will obviously change. This is actually one of the important reasons for the happening of refraction. Why refraction takes place? It is all because of the differentiation in speed of light in different material, in different material or medium. I'm told it is the same, right? So refraction takes place because of the speed of light in different materials. Now in air, if you take, it is going to be something different, like 1 point something. Now if you take in glass slab, it is obviously going to be more. Now that is because it is denser. Okay, now I have to tell you one more thing. Air's density is lesser than obviously glass. So here we have two mediums. So here air is a rarer medium and glass is a denser medium. So when reflection is going to take place, there are two mediums. One is a rarer medium, other one is the denser medium. So rarer medium is lesser density than the denser medium. So obviously when it is having denser medium, when it is a denser medium, the speed of light here it is more than that of the air, because it is a rarer medium. So due to which, like in denser medium, speed is less, actually speed of light is less. That is why it is moving towards the normal in order to make a shortcut. Okay, so that is what are the things you have to understand. And one more thing is wavelength will also change, and speed and velocity is very much important because you will be having one more topic based on that. Okay, so make sure you remember this. And next we're going to see the laws of refraction. So laws of refraction, there are two laws of refraction generally. The first law states that incident ray, refracted ray and normal at point of incidence lie on in same plane. So what does this mean? So first I'll show the figure so that you can understand easily. Now I told this is the incident ray and this is the refracted ray and this is the point of incidence, right? So all this lie on same plane. Even the normal, this is normal, right? Everything are going to lie on same plane, only one plane. Okay, so that is only the first law of refraction. And second law is also called as the Snell's law. Okay, so what does Snell's law state? It states that the ratio between sine of angle of incidence divided by that is a sine of angle of reflection. So refraction for given to optical media is a constant. So sine of angle of incidence divided by sine of angle of refraction, it is a constant. So now what is this constant? You will think, right? In the further concept, we are going to see what is this concept and not in the first concept itself. Okay, not in the very beginning. Okay, so you'll be learning, no need to worry about that. So these are the two laws of refraction. Okay, now let's move on to the next topic. What is that? It is a refractive index. So relative index, sorry, refractive index. In refractive index is generally represented by n or mu. Okay, this is mu. I hope you're not new to it. Okay, so there are two types of refractive index. So first one is absolute refractive index and second one is relative refractive index. And remember 2 points that relative. So generally refractive indexes will not have any units and no dimensional formula. So remember this point, no units and no dimensional formula. Okay, now why it is like that you can understand when I explain refractive and relative index. Okay, so let me explain. Now first we have absolute refractive index. Absolute refractive index is defined as the ratio of speed of light in free space to that of speed of light in given medium. So what does this explain? I'll tell you. See, absolute refractive index is represented by m or n. So that is what is being written here. That is clear to you, even though I have written it again. Okay, so instead of writing mu, you can also use the letter n here. Okay, I have used mu. Okay, yeah. So mu is equal to c by v. Now what is c? It is the speed of light in free space. You can also say it as air. You can also say it as vacuum, because speed of light in air, free space, and vacuum is almost the same. That is simply 1. Okay, so you can roughly take it as 1, but sometimes it will be mentioned in the question. Okay, so you have to use that kind of value. Okay, so now what is v? V is nothing but speed of light in the given medium. Now suppose if he will ask you to find the relative index of diamond. Now you have to find out the speed. He will give you the speed of light in that medium diamond, and if nothing is mentioned, only one medium is there, obviously it is absolute refractive index. Now I hope until here it is clear. Now why we don't have any units? Say speed units both will be same only, right? Meter per second by meter per second, speed units both will get cancelled, so there are obviously no units left. Understood? So that is why refractive index do not have any kind of units. Now this is clear to you. Okay, now for given light, denser is the medium, lesser will be the speed of light, and so greater will be refractive index. See, if the medium is denser, its speed of light will be less. Just now in the I have discussed, right? Here we discussed about that glass is denser medium, that's why speed of light will be less. Air is a rarer medium, so speed of light will be more. I have already explained, so that's what is explained over there. Understood? Next we have to see how refractive index, that is a absolute refractive index, could be found when wavelength is given to us. So it's very simple. First, refractive index, that is mu or n, both you can use. So refractive index is nothing but wavelength. See, wavelength, this not wavelength not by wavelength, so wavelength not represents the wavelength in free space, that is the air or vacuum, and this wavelength symbol represents the medium, so you can call this as lambda not and by lambda. Okay, so that's what. So absolute refractive index when wavelength is given is mu is equal to lambda not by lambda. Okay, so here one value is fixed, that this is the first value, the speed of light in air is fixed. Okay, c is fixed, whereas v will change according to the medium. Understood? So that has to be understood in absolute. Now what is the difference here? What is the relative refractive index? When light passes from one medium to another, the refractive index of medium 2 related to medium 1 is written as relative index of 2 with respect to 1. Now what is given here, I'll explain you, don't worry. First, here relative refractive index. In this, here we are going to find out the ratio between two different transparent medias. Two different medias and speed, we are going to get the ratio. Okay, now how do we tell that? See, two different medias are there, which one to put up, which one to put down, you will get doubt, I know that. Okay, so first when you want to find out the refractive medium or refractive index of medium 2, then you have to say that refractive index of medium 2 with respect to 1. With respect to medium 1 will be nothing but a refractive index of medium 2 divided by refractive index of medium 1. Understood? So I hope this is clear. It will take some time to understand. If you don't understand, you can watch it again, and if you have any queries, you can put in the comment section also. Okay, now so this one is refractive index of medium 2 with respect to medium 1. With respect will come to the left side, and refractive index of what you're finding will come to the right side. Okay, now if I want to find the refractive index of 1 with respect to 2, how it will be? Immediately comment it in the comment section. Refractive index of medium 1 with respect to 2. Okay, so refractive index of medium 1 with respect to 2 is like this, and the formula will be changed. Okay, is equal to mu 1 by mu 2. Okay, this is the formula which will be going to be used. Okay, so first with respect to it will be down, and whatever refractive index you want to find will be up. Remember that shortcut trick. Okay, so this is the thing you should know. Okay, until here I hope you understood. Now let me tell you something. Okay, so here I told you refractive index of medium 2 with respect to 1 is nothing but refractive index of 2 divided by refractive index of medium 1. Now what is the refractive index formula, general formula which we have just seen, absolute refractive index? It is nothing but c by v, that is speed of light in free space divided by speed of light in given media, right? Now when it is given m2 means you're just going to write v2 below. Why it is so? Why not c2? It is speed of light in free space. This is the constant. You can't change it, right? Same value will be there. So that is why C is something which is same. So you don't need to write C1, C2. Okay. So now M2 is nothing but C by V2, and M1 is nothing but C by V1. From the which one? I'll show you. Wait. Yeah. So from this formula we have derived absolute refractive index. Okay. Sorry. Yeah. Here. Now let me substitute these things here. Okay. Let me put them here. So what is M2? C by V2 divided by C by V1. This can be nothing but C by V2 into V1 by C, because here when it is division, when you put multiplication, the other one will be reciprocal. Okay. Now C will get cancelled because the value of speed of light in free space is going to be the same thing. So what is it? Nothing but V1 by V2. Now relative index of medium 2, sorry, refractive index of medium 2 with respect to medium, is it not equal to V1 by V2? Yes, obviously. I'm so sorry. Okay, it is equal to V1 by V2. Understood? Remember this. Next, I'll show you one more thing. Okay, now we will find the refractive index of medium 1 with respect to medium 2. So what will be the formula? Mu1 by mu2. Am I right? Next, what is mu1 value? C by V1. What is mu2 value? C by V2. Now, mu1, so refractive index of medium 1 with respect to medium 2 is nothing but C by V1 by C by V2. So C by V1 into, now this will be reciprocal, right? V2 by C. C will get cancelled, so it is nothing but V2 by V1. Now refractive index of medium 1 with respect to medium 2, is it not V2 by V1? Yeah, it is V2 by V1. Now, we have seen two things. One was refractive index of medium 1 with respect to medium 2, that is nothing but V2 by V1. And we have also seen the refractive index of medium 2 with respect to medium 1, which was V1 by V2. Now, remember these two. Now, what do you observe from these two? What do you observe? So, we observe that both are root of each other. So, we can tell that. So, what we can tell? We can tell this, right? So, the refractive index of medium 2 was just the reciprocal of medium 1, refractive index of medium 1 with respect to medium 2. Big here, okay, I'm showing. So in this slide you can see, right, last slide. So V2 by V1 for the refractive index of medium 1 with respect to medium 2, V2 by V1, and this one, yeah, now it's perfectly all right. So is it not the reciprocal? Both are reciprocals of each other. So that is very much clear to us. So this is nothing but principle of reversibility of light. Now I hope until here you understood. So we have completed the refractive index. So conditions for no refraction. Now when the angle of incidence is 0 degree, there is going to be no refraction. See here, do you find any refraction? No, no refraction. Okay. Next, second condition is, if the refractive indices of both optical media are equal, it suffers no refraction. Now suppose this is one medium and this is one more medium. If both are having same refractive indices, then it has no refraction. Okay. It will be perfectly all right. Okay. Now, if a light node points we have, so let's see the node points 1. If a light ray travels from a rarer medium to a denser medium, then the angle of incidence is greater than angle of refraction. Suppose now this is a glass slab, this is air. So obviously air is rarer medium, glass is denser medium. So here we are sending one incident ray here. This is the normal. So obviously this angle of incidence will be greater, because angle of refraction, what happens, it comes towards the normal, right? So obviously angle of refraction will be smaller. So angle of incidence is greater than angle of refraction. Now the note second point, what is given, let's see. If the light ray passes from a denser medium to a rarer medium, then the angle of incidence is less than angle of refraction. Now suppose this is a glass slab here. Now there is a ray passing from this. Okay, so there is a ray like this. Now it has to come to air. So this is the normal. So let me make a broader. This is the normal. Now when it is going outside, when it is coming to a rarer medium from a denser medium, it generally goes outside like it goes away from the normal. Okay, so in this case, angle of refraction is greater, whereas angle of reflection, angle of incidence is lesser. Understood? So this is two different cases. So I hope you are very much clear with concept 1 as completed. So If you have any queries, you can put it in the comment section, and you can share our videos to your friends so that it will be helpful for them. And do like, share, and subscribe to Vishwablooms. Bye bye. See you in the next video. Until then, stay tuned. Bye.